So this talk is about making sense of Einstein's relativity. As per a previous talk, I pointed out that the usual translation from German into English for Einstein's 1905 paper on special relativity is a mistranslation. So I'm trying to make sense of Einstein's relativity from a better translation. Einstein did not use the terms one-way light speed and two-way light speed, but looking at his paper, he should have used these terms. So now trying to make sense of his paper based on those concepts. And when I refer to light speed, what I mean is light speed in vacuum, and I'm looking at his paper starting from Newtonian physics. Consider a box that's not moving with light bouncing between the two walls of the box. First light goes one way with speed c, c being the speed of light in vacuum. Then light goes the other way with speed c. Speed back and forth is c plus c all divided by 2, and that equals c. So the two-way light speed equals c, and the one-way light speed equals c. Now for considering the box moving. So now we're considering the box moving with speed v in the direction shown. Speed one way for the light is now c minus v, and speed the other way is now c plus v. As for the both way speed, it's at c minus v with c plus v, and then divide it all by 2 and you have c. So the two-way light speed equals c. But the one-way light speed is c minus v and c plus v. This is all by Newtonian physics. Usual translation of Einstein's 1905 paper states, in agreement with experience, we further assume the quantity, which is this equation here, to be a universal constant, the velocity of light in empty space. Now the German word translates either into speed or velocity, and I think it would be better to use the word speed. So he's talking about the speed of light in empty space as a universal constant from that equation. Now to bring in the issue of one-way light speed versus two-way light speed. So he's talking about light going from A to B and then going back to A. Light leaves at time t subscript A, and light returns to A at time t dash subscript A. So the total time of the journey is t dash subscript A minus t subscript A. Thus the equation is giving the two-way light speed. Now there's been a mistranslation in the usual English version of Einstein's 1905 paper, and it's pointed out in this paper, American Journal of Physics in 1963. And the issue seems to boil down to the German words none versus the German word nur. This is the German. And in the German, the word none, N-U-N, has been mistranslated as nur in the usual English translation. So it translates as the latter time can now be defined by defining by definition the time the light takes to travel from A to B is equal to the time it takes to get from B to A. There's nothing about having to compulsorily define time this way, so therefore it's optional to define time that way, and it's called Einstein Poincare clock synchronization. Clocks can be synchronized other ways, but Einstein wants clocks to be synchronized this way, at least in what he's writing in his 1905 paper. So by the Einstein synchronization, the clocks are synchronized so that one-way light speed equals c. There is a general issue: if have two clocks, then how do we synchronize them to get the same rate? And Einstein answers it by this synchronization as to how he wants the clocks synchronized. Clocks are synchronized so that they have one-way light speed equal c. Now contrast this to Newton. Both Newton and Einstein have two-way light speed is equal to c. Newton has one-way light speeds as c minus v and c plus v, and when v is greater than 0, he has c minus v less than c and c plus v as greater than c. Einstein has synchronized things so that one-way light speed is c. So he's replacing c minus v and c plus v, which Newton has, by c. When v equals 0, c minus v and c plus v do equal c. But when v is greater than 0, c minus v and c plus v do not equal c. So consider v equals c. Then c minus v equals c minus c equals 0, and c, for the case of c plus v, that equals c plus c equals 2c. Whereas Einstein wants it to be imposed that it's c. So imposing c on this, he's saying that 0 equals c, and what you can get from that is 0 equals 1 equals 2, which is nonsense. But when v is much less than c, then c minus v approximately equals c, and c plus v approximately equals c. So if you can see that by, if you consider the case of v equals 0.0001c, then the case of c minus 0.0001c is equal to 0.9999c, and that's approximately c. Similarly, if you add 0.0001c to c, then that approximately equals c as well. So Einstein's synchronization is making an approximation and is able to deal with things when v is much less than c. But when v gets too large, then the approximation is no longer adequate. So that's how the one-way and two-way light speeds are connected from Newton to Einstein. Einstein is dealing with an approximation of treating them as all equal to c for low speeds of v much less than c. There are a lot of other problems in relativity, but I've highlighted in this talk one of the main problems. I have highlighted it previously that Einstein has been mistranslated and misrepresented. and Einstein has not dealt with things in a clear way. But the basic thing in this talk is special relativity is an approximation of Newtonian physics, and that is contrary to the way it is normally taught. It's normally said that Newtonian physics is an approximation of special relativity, but on this issue they've got themselves totally confused, and what Einstein is actually doing is making an approximation from Newtonian physics. So the whole understanding of physics has been messed up from this. Thank you, and that's the end of this talk. Cheers.